This video covers notes over scatter plots, which we're using a zombie apocalypse little scenario to help you see all the different types of scatter plots. So in the small town of Shadow Hills that has a population of 100, a biological incident occurs in which one person becomes infected. We're going to call him Zombie Zero. The CDC needs you to analyze 3 different zombie outbreak scenarios. So scenario 1, each day Zombie Zero infects 2 new people, and that is represented here. Scenario 2, Zombie Zero learns how to infect 2 more people than the day before, so that is shown here. And day 3, each day each zombie infects someone new, so that is shown here. So we have the functions here, and step 1, they ask us to classify them as linear, quadratic, or exponential. So this first one, because we just have like a normal everyday linear function, this is going to be an example of linear because we have the letter D for days, and it's just a normal, it's not D squared and it's not a little d. Scenario 2 has a D squared, which would be quadratic, and scenario 3 has D in the exponent, so that would be exponential. So step 2, they want us to fill in the table. So I'm going to put these into Y1, Y2, and Y3. And I don't have to look at them all at the same time, but then that way I have them all listed. So I have 2x plus 1, x squared plus x plus 1, and 2 raised to the x. So to fill in this table, I'm going to look at 0, they're all 1s across the board. So if I just want to go down, and I'll use the same colors as the calculator. So this is 3, 5, 7, 9, 11, 13, and 15. And remember that you can pause this video to write them down if you need. Y2, we have 1, 3, 7, 13, 21, 31, 43, and 57. And then Y3, we have 1, and then it goes to 2, 4, 8, 16, 32, 64, and 128. So remember, you can pause now if you need some of this. So part 3, they've asked us to graph the scenarios on this piece. So I'm going to go ahead and graph those. So scenario 1 we had in blue, and on the blue we started with the point 0, 1. And then when x is 1, y was 3. 2 is 5, 3, 7, 4, 9, 5, 11, 6, 13, and 7, 15. Okay, so we can see that that is pretty much a straight line. And remember, you can pause this if you need. Scenario 2 was our quadratic. So we start 1, 3, 7, 13, 21, 31, 43, and 57. So we can see that looks like a nice U shape there. And then scenario 3 in the black starts at 1. 1 goes to 2, so a little bit below. 2 goes to 4, so again below. 3 to 8, so now we've hopped over the blue line. 4 to 16. 5 to 32, and now we've hopped over the red line. 6 is at 64. And 7 is way up here at 128. So we can see this one, even though it took a little bit longer to get started, this one ended up affecting way more people when it came down to 7 days. So at 7 days, the blue line only has 15 people, red has 57, and black has 128. So it's quite a difference there. So then part 4, answer the following. How many zombies are there on day 7? So day 7, we have 15 for the red equation, 57 for the, I said red. 15 for blue, 57 for red, and 128 for scenario 3. And then find the value of Z5. So remember, inside is always an X, or in this case, D for days. So 11 for blue, 31 for red, and 32 for black. Find the smallest value of days so that the zombies are zombies are greater than 10. The smallest amount of days where you have more than 10 zombies. So zombies greater than 10, or 10 is less than your zombies. So that would be, what, 5 days in here? 5 days we have more than 10 zombies. So 5 days for blue. And then more than 10 would be 3 days for red. And more than 10 would be 4 days for black. And then how long will it take for half the population to become zombies? So remember, back up at the front, they told us that there's a population of 100. So we are looking for where y equals 50, or between 50. So in the black, it's going to take about 5.5 days. It's somewhere between 5 and 6. And then 6 and 7. So we'll do 6.5. They're not asking for us to be exact here. And then for the linear, somewhere between 24 and 25. And then for the entire population to be affected, so all 100, so between 49 and 50 on blue. Red looking for 100. Or over 100. So between 9 and 10. And then black between 6 and 7. Okay. Then part 5, they're asking for us to do 1, 2, or 3 for each scenario. So days 0 to 2, which one started off with the fastest increase? So days 0 to 2 right here. The fastest increase would be red, which is scenario 2. Slowest increase in that same time would definitely be black, because the black did not take off the same way. Largest increase from days 2 to 3, so right here. Or if we want to look back at the table, we can. So 2 to 3. Let's see, scenario 1 goes up 2. The red goes up 5, or 6, 6, and black goes up 4, so that'd be scenario 2 again. Oops. And then who took over the population first is scenario 3. We saw that here. They would take over the fastest to become zombies. And then they just have some true-false questions. So scenario 3, the zombies double each day. That is true. That's what the 2 raised to the x, your rate is 2. On day 4, zombies is greater than 10 in all scenarios. So day 4, that is not true, because scenario 1 is not. Scenario 1, rate of change with respect to days is 2. That is true, because we have 2 times d. All scenarios have graphs with a y-intercept of 0, 1. That is true. We have 0, 1, 0, 1, 0, 1. So all of them have the same y-intercept. On day 2, zombies in scenario 1 equals day 2. Day 2. Zombies in scenario 1 equals zombies in scenario 2. That is false. All scenarios have a graph root at 1, 0. So when x is 1, y is 0. That is not true. If we look right here, when x is 1, y is not 0. Sorry, you could have seen that from the graph. So when x is 1, y is 3, 3, and 2. And then 8 to 9 and the days, The zombies in scenario 2, so 8 to 9. Oh, I'm going to have to look at the calculator for that. So scenario 2, days 8 to 9, so we go from 91 to 73. So if you're not sure, 91 minus 73. And there's a total of 18 days, so that is true.